In 2025, researchers discovered bees can discriminate between quantities up to 4 and grasp the concept of zero-something that stumps many computer algorithms. Studies found these insects can count backwards through basic addition and even understand abstract mathematical concepts. But here's where it gets absolutely mind-blowing. Bees achieve these numerical tasks despite having incredibly tiny brains with simple neural networks. These flying mathematicians are performing calculations that would challenge many humans, and we've been treating them like they're just annoying pests. The discoveries about bee intelligence are just the beginning of what 2025 research revealed about animal minds. Octopuses are rewriting computer science. Octopuses are rewriting the rules of computer science with neural networks that make our most advanced systems look primitive. Silicon Valley engineers have been studying these 8-armed creatures after discovering their problem-solving abilities operate on principles that could revolutionize artificial intelligence. The breakthrough came when researchers realized octopuses don't think like humans or computers at all. While we process information in a linear sequence and computers follow predetermined pathways, octopuses use distributed intelligence that operates more like a quantum system. Each of their 8 arms contains roughly 40 million neurons, which is more than most mammals have in their entire brains. These arm brains can taste, touch, and even make basic decisions without consulting the central brain. When an octopus encounters a complex problem, each arm essentially becomes a separate processing unit working on different aspects of the challenge simultaneously. Recent research has shown that cephalopods, including octopuses and cuttlefish, have passed cognitive tests originally designed for human children. Cuttlefish demonstrated episodic-like memory capabilities by remembering what they ate, where they found it, and when the meal occurred. This type of memory was previously thought to exist only in humans and a few other highly intelligent species. The tests revealed that these creatures can plan for future events and make decisions based on past experiences in ways that challenge our understanding of animal cognition. The distributed processing model that octopuses use naturally could revolutionize everything from autonomous vehicles to financial trading algorithms. Traditional computers process information through a central processor that creates bottlenecks when handling multiple complex tasks. Octopus brains eliminate these bottlenecks by spreading the processing load across multiple semi-independent units that work together seamlessly. But the real shocker came when researchers started filming octopuses in group settings. They discovered that octopuses can teach other octopuses complex problem-solving techniques through observation alone. In one experiment, a trained octopus learned to open a series of increasingly complex puzzle boxes. When researchers introduced untrained octopuses to the same enclosure, the trained octopus began demonstrating the solutions. The student octopuses watched intently as the teacher manipulated latches, turned dials, and coordinated multiple arms to access hidden treats inside the boxes. What made this discovery extraordinary was the speed of learning transfer. Human students might need multiple demonstrations and practice sessions to master complex tasks. The student octopuses grasped the concepts after watching just 2 or 3 demonstrations. More incredibly, they began improvising their own solutions based on the teacher's techniques. One student octopus figured out how to open a puzzle box using 6 arms instead of 8, creating a more efficient solution than the teacher had demonstrated. Another student discovered that certain sequences could be performed simultaneously rather than sequentially cutting the solution time in half. The teaching behavior wasn't limited to puzzle solving. Researchers documented octopuses sharing hunting strategies, camouflage techniques, and even social behaviors. Older octopuses would position themselves where younger ones could observe their actions, almost like deliberate instruction. The younger octopuses showed clear learning patterns, adopting successful techniques while discarding ineffective approaches. This level of social learning was previously thought to exist only in highly social mammals like dolphins and primates. The footage revealed something even more remarkable about octopus intelligence. These creatures don't just learn and teach, they actively experiment with new approaches. One octopus spent several days trying different methods to extract food from a container with multiple openings, rather than settling on the first successful technique. The octopus continued testing alternatives, eventually developing 3 distinct methods depending on the type of food involved. This kind of flexible problem-solving demonstrates abstract thinking that rivals human cognitive abilities. Tech engineers studying these behaviors realized that octopus intelligence operates on principles completely different from human or artificial intelligence. While humans rely heavily on memory and pattern recognition, octopuses seem to approach each problem as a unique challenge requiring creative solutions. Their distributed neural networks allow them to consider multiple possibilities simultaneously without getting locked into predetermined patterns. This flexibility could be the key to developing AI systems that adapt to new situations rather than simply following programmed responses. The research revealed that octopus problem solving involves a level of coordination between independent processing units that exceeds anything engineers have achieved in distributed computing systems. Each arm can work on separate aspects of a problem while maintaining constant communication with the other arms in the central brain. The coordination happens without any apparent central control system, suggesting that octopus intelligence emerges from the interactions between semi-independent units rather than top-down processing. Companies are now investing millions in octopus-inspired computing architectures. The military has shown particular interest in applying these principles to drone swarm coordination, where multiple units need to work together without central command structures. Financial firms are exploring octopus-based algorithms for high-frequency trading systems that need to process multiple data streams simultaneously. Even video game developers are studying octopus neural networks to create more realistic artificial intelligence for non-player characters. The broader implications extend far beyond technology. Octopus intelligence challenges our fundamental assumptions about consciousness and cognitive ability. These creatures evolved completely independently from vertebrates, yet developed problem-solving capabilities that match or exceed many mammals. Their success at intelligence can emerge from radically different neural architectures than the ones we're familiar with in human and mammalian brains. Perhaps most intriguingly, octopuses might represent our closest encounter with truly alien intelligence. Their neural organization, sensory capabilities, and problem-solving approaches differ so dramatically from terrestrial mammals that studying them could prepare us for recognizing intelligence in forms we might encounter beyond Earth.